Wow, our last video of the week. How exciting. So there's two special cases whenever you have variables on both sides. The first one is no reals, when nothing will work for that problem. So let's see what I mean. You solve this, you have 5x plus 6. Here you distribute the 5. It's 5x plus 30. Now, notice how can you multiply something by 5, add 6 to it, and get the same thing if you multiply by 5, then add 30? That doesn't even make sense. Holy cheese. But let's say we didn't notice that. So we go to solve it. I subtract the 5x's. I got 6 equals 30. Well, that doesn't make sense. That'd be like saying, okay, I'll give you $6, you give me 30, and we're even. That's not right. So whenever the variables drop out and it's a wrong statement, false, it's no reals. Now, different people call it different things. I've seen empty set, no solutions. I like no reals. And this one, okay, notice, let's see, distribute the half, you get 3x plus 5 equals 3x plus 5. Well, no matter what I put in for x, it's going to be true. It's always true. You triple and add 5 and triple and add 5. Mercy. So let's say we didn't notice that. I subtract 3x, I subtract 3x. Oh, 5 equals 5. Well, that's always true. So no matter what I put in, it's going to be true. I like all reals. Now, some books call it identity. I don't know. I don't like that because to me it doesn't sound like what it is, all reals. So if you see identity in the book, well, that's what it means, all reals. But I like all reals. Everything works. So I have 3 little problems for you right there. Freeze the camera, then jew 'em. Okay. So distribute the x, distribute the negative, which whenever you got a negative out front, that's the same as -1. So take the opposite of everything or multiply by -1, x. So I'm going to add x to get the x's to one side, -x plus x, that's 0. So 6 equals 2x. Divide by dosa. Oh, x equals 3. That's an answer, so it's not a special case. I tricked you. So combine 2x minus x is x. Now, right here, if you see the same thing as on both sides, you say, well, I see same thing on both sides, so it must be all reals. Or if you want to go ahead and solve it, that's okay with me. So it'd be all reals. It's always true. 10 equals 10, silly. Subtract x, 6 equals 5. Well, that's never true, so nothing could work. How you can take a number, add 6 to it, and get the same thing if you add 5? No, should be no reals. Now, we're going to start the next week. Today, since we have a little time, we're going to start working with inequalities next week. So you have, whenever the mouth of the symbol is trying to go to the left, that's greater than. Whenever the arrows point to left, that's less than. So greater than or equal to, or less than or equal to. Now, a long time ago, I had a student said, Mr. Murphy never said anything, raised his hand, and he said, oh, I was taught it this way. The mouth is always trying to eat the bigger item. So he said, make a little dinosaur. But the trouble is, my dinosaur always looks like a demented Pac-Man. But if you want to remember it that way, the mouth is always trying to eat the bigger item, or it's always trying to point to the smaller item. However you want to look at it is fine with me. So, we're going to start next week solving linear inequalities. So, if I have 2x plus 1 is greater than 11, you solve it just like an equals, except for one thing, which I'm going to show you in a minute. But I get rid of the 1, so subtract 1. 2x is greater than 10. Then divide by the 2. Now, with inequality, since you're talking about infinity, they like for you to actually graph it. Now, here's how you graph an inequality. You put a dot around the number on the number line. So it's 5. Now, there's no equal, so it's an open dot. Then you shade the numbers that cause it to be true. In this case, 6 is bigger than 5, so I'd shade this way. Now, if I have this, negative x minus 6 is greater than or equal to 10, well, I would add 6. Okay, we can do that. Oops. Then I'm going to divide by negative 1. But whenever you multiply or divide by a negative, you actually have to switch the inequality. And it has to do with the number system. Let's say I got negative 2, 2. Oops, that's negative 1. Sorry about that. 0, 1, 2. So if I say that 1 is bigger than negative 2, if I multiply both sides by a negative, this is now negative 1 and this is now 2, which causes the statement to switch the inequality because negative 1 is smaller. So I started off here and I started off here. 1 is to the right, so it's bigger. But when I take the opposite, 1 comes here on the other side, but negative 2 comes over here on the other side of 0, making 2 to the right and negative 1. So therefore, you have to remember that whenever you multiply, that's supposed to be you, multiply or divide by a negative, you must switch the inequality. Now this I would graph negative 17, negative 16. I only really need 3 numbers. Some teacher wants you to start at 0, but holy cow, that'd be huge. It's an equal, so it'd be solid dot and to the left. Now this is what we're going to start with on next week. Next weekend I'll make videos on this, inequalities. But your homework will be page 15, 37 to 42, and page 23, 35 to 42, and 53 to 58. Now, I plan to put this on Schoology, but my 8th graders probably won't have Schoology yet. So that's your homework, only 2 pages. I kept it nice for ya. Hey, have a good day.